Okay, I think now is the right time. Hello, everyone. Welcome to this meetup. So today we are very happy to invite DV from Delhivery and Bhanu from PingCAP to deliver some talks about real-time analytics. Before we start, I want to make some introduction about the TIDB India user group. I'm Michael, so I'm from PingCAP. And for TIDB community, it's a group for sharing and learning, established by developers, users, contributors, and partners in the TIDB ecosystem. By now, we have more than 2,000 developers around the world, and the goal of this community is for learning TIDB with the help of TIDB users and experts, ask for any questions, and connect with TIDB users and engineers around the world. So here's some online resource for you to ask for questions. Besides this meetup, you can use this TIDB forum. And also we have some website about docs. You can explore how to guide and get more reference when you use the TIDB cloud. And here are some courses and certification provided by PingCAP for TIDB learning. We have training and workshops, and we have a developer certification program, and we have a database operations certification program. You can check this website at pingcap.com/education and get more information. And by the way, so here is user group. So welcome to invite your friends to join this group, as we will have more technical sharing in the future from time to time. And now let me hand over to ADB, and you can start the technical sharing. Hey, ADB, now I transfer to you.
Thanks, Michael. Just give me a moment. Let me present my screen first. Hope my screen is visible to everyone.
Yes, I can see it.
All right. So, hi, everyone. Today, I'll guide you through a journey of real-time analytics using TIDB. But first, let me introduce myself first. I'm Akash. I'm currently leading several initiatives in the area of data engineering, data services, and DevOps at Delhivery. Now, without further ado, let's dive into our exciting journey. Let me first highlight the scale and magnitude of our operations. Delhivery is largest e-commerce logistics company in India, serving over 18,500 pin codes across the country. We have successfully delivered more than 2 billion parcels and operate an extensive infrastructure spanning approximately 18 million square feet. Our operations are powered by a suite of 80 plus technology applications supporting a client base of over 27,000 active clients. And to manage this vast logistics network, we have a daily operating fleet of 11,000 plus vehicles. Now, let's delve into a specific example to illustrate the challenge we faced with our mid-mile logistics infrastructure, where I'll focus on one of our mega facilities to provide insight into the complexity and scale of the issues at hand. So this particular mega facility boasts an expansive shared area covering approximately 550,000 square feet, which is equivalent to a parameter of nearly 2 kilometers. Its primary operations revolve around the sorting of shipments in bags. There are close to 131 vehicle logs, which you can see over here, which are handling around 400,000 bags daily, both for incoming and outgoing shipments. Also, this facility plays a crucial role in managing hub and processing center operations. In the hub, it oversees inbound and outbound operations, including bag sorting activities. And for the processing center, it handles B2C first mile inbound operations, utilizing high-speed shipment sorters for efficient processing. However, operating smoothly within such large mega facility present us three significant operational challenges that requires attention and resolution. The first challenge, where the operator immediate requirement is to have a real-time visibility within the facility. They need to know the number of shipments currently inside the facility, the status of vehicle, including their timeliness, and the number of vehicles stocked, and the manpower situation at any given moment, of course. Now, similarly, in the real-time prioritization, it is crucial to streamline operations. Here, the operator needs to make decisions regarding how and where to dock trucks within the facility, the order in which truck should be loaded or unloaded, and prioritizing the unloading or loading of specific shipments. And in this section, which is real-time in-facility actions, it presents additional challenges, which are locating specific shipment or bag within the facility, which usually can be a daunting task, accessing floor plans to understand the layout and optimize movement, and monitoring manpower activity to ensure efficient utilization. Now, to overcome these challenges, we require a comprehensive system that offers near real-time visibility, guides operational decisions, and defines the next set of actions, such as will provide the necessary tools to enhance operational efficiency and optimize the overall performance of the facility. Now, with that, there are some requirements and constraints. The requirement is to perform real-time transactions effectively, absurds, as many real-time scenarios necessitate fetching the latest events, while also enabling low latency extraction from the database. However, achieving this goal encounters certain limitations. Assume if we go with the OLTP databases, uh, maybe utilizing OLTP databases for real-time analytical use cases can impede performance. In fact, high read IOPS can lead to increased costs and slow down analytical queries. Similarly, in the OLAP databases, employing OLAP database can result in increased write latencies where handling real-time data is difficult. That hampers the ability to achieve low latency extraction. So what else? To address these requirements and constraints, there is a need for HTAP database. By combining the capabilities of both OLTP and OLAP database, HTAP database can provide the necessary infrastructure to support real-time upserts, low latency extractions, and efficient analytical queries without compromising performance. Now, how HTAP can provide solutions? By leveraging HTAP technology, we can address the challenges mentioned earlier and unlock several benefits. It could be cost reduction, where HTAP database can reduce the cost associated with the high read IOPS high read IOPS, and in fact, by combining transactional and analytical workloads in a single database. It eliminates the need for separate infrastructure for each use case, which results in cost saving. Another important thing, it leverages atomic operations, ensuring data consistency and integrity during simultaneous transactional analytical processes. This capability enhances data reliability and accuracy. And the next is the faster decision making. With this, organization can achieve faster decision-making capabilities, real-time analytics combined with transactional data processing, which enables timely insights, empowering business to make informed decisions safely. Now, while working in this space, we figured out TIDB is an exemplary distributed true HTAP database that combines the advantages of both OLTP and OLAP layer. Here, TIKV specifically serves as a transitional storage, which within TIDB, ensuring efficient processing of transitional workload. It provides horizontal scalability, fault tolerance, accommodating the need of modern and cloud-native applications. Similarly, in the TiFlash, it handles the analytical workload, offering high-performance query for large-scale data analytics. It empowers users to perform near real-time analytics on massive datasets. And TIDB is a distributed architecture. Scalability and fault-tolerant design make it an ideal choice for us, seeking a powerful HTAP database solution. It harnesses the benefit of both OLTP and OLAP database, which enables business to leverage real-time insight for faster decision-making and drive better business outcomes. Now let's discuss how we have implemented the solution in motion. We have a range of application microservices that are operated either by on-ground staff or by the system itself. Now, before taking any action, it is crucial to have a clear understanding of the current situation within the facility. That includes parameters such as number of parcels, vehicles, and manpower involved, which are processed and managed by these applications or microservice. Moving on, here to see together and process this data effectively, we extract it from these microservices and push it to Kafka messaging system. Here, the real-time aggregation is performed wherever possible to ensure timely insights. And subsequently, the aggregate data is pushed to TIDB. That allows for efficient storage, analysis, and retrieval of the data. Further, the analyzed data from TIDB can then be accessed and visualized using business intelligence tools, which further, these front-end applications are designed and deployed to serve this information through interactive charts, widgets, and other visual representations. This enables to gain valuable insights from the data, which aids in decision-making and drive operational efficiency within the facility. Now, this is a zoomed-in version. This represents a detailed view of our data architecture. In this setup, we efficiently consume data from various disparate sources using CDC and then route it to Kafka, our streaming platform. The majority of our stream processing occurs during the utilization of the Kafka Connect framework. Now, after this, the data is denormalized and forwarded to downstream systems. Additionally, we prepare real-time data marts with TIDB which is our HTAP database, where the data is stored and organized for optimal querying and analysis. These real-time data marts serve as a these near real-time data marts serve as a valuable source of data. I'm just correcting here myself because sort of it's confusing term, which is real-time versus near real-time, but of course this is near real-time. So these near real-time data marts, serves as a variable source of data for various data visualization engines and tools. Now, by employing this architecture, we ensure the seamless flow of the data from multiple sources, enabling real-time processing, efficient data storage, and the generation of valuable insights. This facilitates the integration of data visualization tools, empowering users to explore and derive meaningful information from the collected data. Now, let me try to relate this with our mid-mile megafacility problem, where we talked about real-time visibility, prioritization, and real-time in-facility actions. Now here, in secondary sorting and put away, our space recommendation engines combine script data with back data and fetches aggregated information from the TIDB in near real time. That suggests which area within the facility should be chosen for putting away bags based on their next destination location. This not only offers visibility into our compliance, but also provides real-time insights into hub utilization. In picking an outbound section, our expected path algorithm combines the truck docking information facilitates the prioritization of bag picking based on the promised delivery dates. And using these priorities, we dynamically select the appropriate connection and trucks that are departing from the respective destination in near real time by combining vehicle data and routes in TIDB, considering the ever-changing network, which keeps on changing every minute. Now, by leveraging these capabilities, our solution optimizes the process of secondary sorting, put away, picking, and outbound operation within the large facilities, which enables real-time decision-making, enhances operational efficiency, and improves the overall performance of our logistics operation by bringing all three, which is near real-time visibility, near real-time prioritization, and defining real-time in-facility actions. And yeah, that's it. That concludes my presentation. Thank you for listening attentively. Now I would like to pass to Bhanu, who will enlighten us about hybrid query processing in Azure databases. While Bhanu takes the stage, feel free to post any questions you may have in the chat. I'll be glad to address them. Over to you, Bhanu.
Thank you, Erivi. Let me just share my screen. Okay, so once again, hello everybody, and thank you for being part of this meetup today. I think I would like to first of all appreciate ADB's sharing and sharing his insights of his architecture and how TIDB is powering the current solution in terms of logistic delivery. So
hey, Bhanu, I think you should switch the speaker view. Now I can see all the notes here.
Okay, 1 minute. Just give me a minute. Does that work now?
No, still same.
How about now?
Oh, it's okay now. Thank you.
Okay, yeah, all right, thank you. So yeah, so again, thank you, ADB, for that session and quick insights into your existing architecture and your application. So for next 15 minutes, I'm going to quickly talk about the topic of hybrid query processing in HTAP databases. Just a quick introduction. My name is Bhanu, and I lead the pre-sales business for Asia Pacific for PingCAP. Okay, so before we just dive into it, this is a quick introduction about PingCAP for those who have not heard about this organization. If you see the two logos on the top, there is PingCAP, which is the name of the company, and TIDB, which is the name of the database. So PingCAP was formed back in 2015, and since then we have grown with over 650 employees. We are a unicorn into the database market, and we have one mission, which is to empower engineers to innovate with speed, agility, and scale. Talking about TIDB as a database, if you see on the right-hand side, we have got this statistics from GitHub. And generally, if you are a GitHub user, you would have observed that for every repo which is on GitHub, there are stars which are given by the open source community. And with that regards, you would see that TIDB is probably almost at the top in terms of the open source adoption as of now. And the TIKB, which is another component, which I'm going to touch base a little later, is also probably on the top 10 list of databases which have been adopted, in terms of the open source community. Okay, so let's talk about some of our global customers who are using TIDB as of today. We have 2,000 plus global adopters who are using TIDB in production. Starting with the first row, you would see Flipkart being one of our biggest customers who have adopted TIDB. We have Delhivery as our another strategic key partner who has been adopting and running their logistics application on TIDB. And then we have a few other open source community customers as well, with the likes of Zomato and Razorpay, who are on TIDB. However, other than that, if we talk about some other customers, we are talking about customers in almost every vertical. We have big names like Airbnb and Pinterest who have very unique use cases which they're trying to solve on TIDB. We are strong in logistics. We are strong in banking, FSI sector. A lot of Web3 customers recently are finding the right use cases on TIDB. The reason being, the TIDB database is a modern distributed database which supports modern applications and supports digital innovation. So let's get into the topic. And before I get into how the HTAP queries are actually executed, I thought I'll just start with the term itself, the HTAP. I'm sure this term is known to most of you, but for those who don't know it, HTAP actually means the hybrid transactional analytical processing, which is a combination of OLTP and OLAP databases, or the workloads, I would say. OLTP workloads are generally those which process high transactional workloads. When we talk about transactional workloads, we're talking about high QPS, anywhere ranging from 10,000 QPS to all the way up to 1 million or even more QPS per second. And probably the latency expectations are down to anywhere ranging from 5 milliseconds to 50 milliseconds, right? Just giving a rough range. And then when we talk about OLAP, we are talking about those use cases where you are performing analytics, where you're running analytical queries. The nature of such queries are different. Here, you're talking about lower concurrency, your throughput is not that high, but you're focusing more on running analytics on a historical data. And so that's where TIDB brings that distributed architecture, which can actually run both these kind of workloads on one single system. So quickly talking about the architecture of TIDB, if you kind of see the layer, which is called as compute layer, this is where the TIDB layer falls in, and this understands the MySQL protocol. So for any existing applications which are on MySQL and they intend to or plan to move to TIDB, that can be done without any code migration and can be moved as is. That's the layer which understands the SQL, and it's actually the computation layer where all the computation and aggregation takes place. On the right-hand side, you would see a PD cluster, which is a set of 3 PD nodes, which are basically the metadata manager of this entire architecture. And then if you go down, you would see the storage layer, which has 2 components. One is called the TIKB, and the other one is called TIFlash. The TIKB is the transactional layer. This is where the data gets stored in a row-oriented format, and the name of TIKB comes from key value. So the data is actually stored in a key value pairs. So this kind of enhances and allows TIDB to give that high throughput and low latency because of its underlying data format and the format in which the data is stored. In addition, there is also another copy which is created on type flash, which we call it as an analytical layer. The data here is kind of stored in a columnar format, which most of the big data platforms or the data warehousing databases would store into. So we store the data into a columnar format, and for any analytical queries, we fetch the data from type flash. And I'm going to talk about this a little bit more later. So why TIDB? The question comes in, and the answer to that is first that the TIDB is built for scale. TIDB kind of eliminates one of the biggest challenges, which customers face when their data is growing and they have more usage of MySQL databases. So TIDB eliminates the need of doing any manual sharding of your data. Because TIDB is a distributed database, so the data gets automatically sharded on all its underlying nodes, and it does provide global distributed asset transaction, which becomes critical for such applications, which cannot afford to lose any data and always needs data in a consistent state. There is a built-in high availability into TIDB, so TIDB can actually be configured on a multi-availability zone or a multi-raft replication. There's a full SQL support along with TIDB. So as I said, existing applications, if they're on MySQL, then that is a direct integration. But if there are any other databases like Postgres, the SQL can actually be run on TIDB with minimal changes. And finally, TIDB brings in a complete ecosystem of handling your data, whether it is data dumping, data loading, whether you want to migrate data from your existing database to TIDB, backups, or using TiCDC. We call it as CDC, which is a change data capture tool. And in terms of competitive positioning, and we generally talk about this slide just to say where TIDB comes into the play and what gaps are being filled by TIDB. If you see, there are one type of databases which are data lakes or data warehouses. These databases are great in storing lots of data, maybe up to petabytes or even exabytes, but their latency is generally at about 5 seconds or more, right? And that's how these databases are designed for. There's no specific need for any lower latency than that. And these databases generally do analytical processing. Then we have databases which are single node databases, where we talk about MySQL, we talk about MariaDB, we talk about Postgres and others. These databases are good in low latency. Low latency can be expected as low as probably 1 millisecond to 10 millisecond. But the challenge with these databases are that they cannot really grow beyond a certain data size. And the moment these databases start growing beyond that, there is a performance glitch. So there's a performance challenge which starts coming in. And then there are alternatives which needs to be performed. Either the data has to be manually sharded onto some other databases and a manual cluster has to be made, or there are other ways to kind of perform that, but all that kind of increases the complexity. So the space which is in between these two kind of databases is something which TIDB fills in, because TIDB can offer you low latency queries based on your use cases. You can start as small as 500 GB, and you can continue to grow on TIDB as your data demands. We are coming up with a new feature in TIDB probably later this year or probably next year, where we will be able to store up to 1 petabytes of data on one single TIDB cluster. Now let's talk about back to the topic of HTAP. HTAP is a simple concept, as I was saying. It's a combination of transaction and analytical processing, which is something I was explaining earlier. Now, why generally is HTAP needed? So I think HTAP does bring in a few advantages for applications. One is that the operations become really simpler, because now instead of many databases managing multiple OLTP and multiple OLAP databases, you can actually have one single system and have your data loaded onto one single system. Obviously, it depends on the scenarios which you're running. You can launch new features a lot more faster because now you have a simplified data stack. You're talking about one single cluster. You can create a single source of truth for both OLTP and OLAP transactions. Otherwise, the traditional way to do it is that you have a separate OLTP and a separate OLAP database, and then generally you will have an ETL between these two. But adding both workloads onto one single system, always ensures that you have one single source of truth copy with you. Another critical part is securing your single data stack. Securing is always a challenge, and ensuring that your data does not have a security breach. So securing a single data stack is a lot more easier than securing multiple copies of data. Your data access is always real time when you talk about HTAP. So you can actually perform selective analytics with sub-second queries, and you really do not need to wait for your data to be traveled through the ETL process from OLTP systems, and then you get a chance to analyze that data. So you get access to that data in real time with HTAP architecture. And finally, you can lower down your TCO for scenarios. We have seen customers who have been using combinations of OLTP and OLAP for certain scenarios, and when merging that into one single system has definitely lowered down their cost. Okay, now this is a very simple question where why TP databases are not really good at analytical processing, and I think the simple answer to that is that your TP databases would store data in a row-oriented formats, whereas your AP databases store data in a columnar format. So imagine if you are doing, if you're selecting all the columns from a row, I think then your row formats are always great and would perform the best. But imagine if you're doing an aggregation on one single column on a TP database, you would still have to scan through all the rows in that table and only be able to then do that aggregation. Whereas if the data is already on a TP database and it's in a columnar format, then you can just only pick data from that particular column and eliminate reads from all other columns. So this is what enhances your performance and better results. So for TIDB, as I was talking about the architecture earlier, the analytical engine we have is called TIFlash, which is basically a columnar storage and with vectorized processing. The data is synced via an extended raft consensus algorithm, and we offer strong consistency on data on TIFlash with very trivial overhead. More importantly, generally when you are running transactions and you're running analytics on one single platform, one single database, there are high chances that higher analytical queries or heavy analytical queries may impact your transactional overheads, your transactional systems. But in TIDB, that's not the case, because if you remember the architecture I've shared, we isolate the two storages. Transactional layer is on TIKV, whereas analytical layer is on TIFlash. And finally, we have a tight integration with the TIDB. Okay, and talking about in terms of how do we really do the data replication within TIDB. So you have, we follow something called a raft protocol. So that means that if we have, let's say, 3 TIKVs, the moment the data is loaded onto one TIKV, a copy of that is also replicated on TIFlash in real time, right? So you get access to data and you get access to doing your real-time analytics the moment your data is loaded on the system. If you've heard about MPP mode, MPP is massively parallel processing, which again, most of the data warehousing solutions like BigQuery or Redshift or Teradata follows. And MPP actually means that every single node has its own resources, has its own CPU, memory, storage, and they would do the processing locally on the machine and send back the results up to the upper layer. And with MPP mode on, this kind of enhances and improves your performance, especially for heavy analytics, and especially where you're reading lots or you're reading a bigger data volume of data. Right. Now let's just see a quick illustration of how do we generally perform. So let's say if a query is executed, which is on your left, the user does not really need to decide from where the data would be fetched. It's a TIDB optimizer which will decide on the fly whether it's a point select query. In this case, it has decided it's a point select query, so it fetched the data from TIDB. There would be a case where you would write, let's say, an analytical query. This is obviously for illustration, but and it may be a simplified example, but this is just to show that if in case you've written an aggregated query and you're doing few joins, TIDB optimizer may realize that it's an aggregated query. And in this case, it can go and fetch data from TIFlash, which is our analytical storage. And there could also be a combination of accessing data from both the storage, both the underlying storage. Again, considering the type of query which you have executed. So in this case, the optimizer has kind of agreed that this is an aggregated plus point select query. So the data can also be fetched from both the underlying nodes to kind of enhance and improve the performance, which is the true value of HTAP database. Okay, so I think later on, this is just for reference for all those. You can always go to ossinsight.io. This is a web page which has been created by PingCAP, where we source in all the data from GitHub to this page. Currently, we are storing above 6 billion records in one single TIDB table, and we are still able to run analytical queries and produce results in milliseconds. So you can try this out. And if in case you have any GitHub repositories, you can always search your GitHub repositories on the search bar, which you can see in this one. All right. So finally, for those who are interested, here is a quick QR code for TIDB documentation, if in case you want to read more. And for those who would like to join our community Slack channel, has a QR code for that. You can always join our community and see the topics being discussed on our Slack channel. And also, if you are ever trying TIDB or you need any further information on TIDB, you can always reach out to us on the Slack channel, and we will happily respond back to you. All right, with that, thank you. And I think probably we'll just open it up for questions and respond to that. I'll stop my sharing.
Thank you, Bhanu. So I think we have some questions. So the first question is to ADB. How does incorporating new technology look like in Indian companies?
Sorry, Michael, can you repeat again?
How does incorporating new technology look like in Indian companies?
So we are operational operations company which is driven by technology over here, and the challenges that we have seen, because we keep on enhancing our products, and the real-time visibility is very, very important. So while brainstorming on those, we did look on multiple areas, the CNCF landscape, and we did evaluate a lot of other databases too before finalizing on this. And that's how we researched and figured it out, and end up doing this choice, which really worked out for us. Yeah, so if that answers.
So I think that's pretty much for the question list. Okay, another question to Bhanu. With the recent type of LLMs and Gen AI, are there any vector database features like dot product and Euclidean functions in TIDB?
Yes, thank you for that question. So yes, I'm aware of that, and probably I've read about those, but those features we do not support because I think we are specifically focusing on bringing in a heavy amount of transactional data to TIDB. and at the same time giving that capability of performing analytics over the same data. So we do not support these features yet on TIDB.
Okay, thank you, Bhanu. So any more questions? So you can just type in the Q&A. We will wait for a few more minutes to see if there is any further questions. Okay, here is another question. Since TIDB is an open source database, can we expect the features of vector database in the future release?
Yeah, so as of now, that's not in the roadmap, but I think just to let you know, we continue to have our hackathons quite often. In fact, about last year during our hackathon exercise, and we from the open source community, we did get a lot of good ideas. For example, one of it was to run TiGraph, so run graph analytics on TIDB. So we do evaluate these features, and probably for vector databases, as of now, there's not in the roadmap, but we can always internally check depending on the requirements and demand from our customers. If that is needed, then probably we can look into it. But as of now, it's not in the roadmap.
Okay, thank you. Next question. Do we need to set up TiFlash separately, or is it part of the TIDB itself?
Yes, thanks for the question, Aslam. So this TiFlash is part of the TIDB setup. However, TiFlash is an optional layer. Because not all customers need analytical use cases. So, for those who only need transactional use cases, we will only set up TIDB and TiKB. But for cases where real-time analytical use cases are existent, we will also configure TiFlash. And this is all part of one-time configuration. You just need to decide initially if you want to have TiFlash. If yes, then once you put that in your configuration, your TiFlash would be configured automatically. So the short answer, it comes out of the box, and you just need to decide at the time of configuration whether you need TiFlash or not.
Okay. Next question in only 2 words. I don't know if it's a comment or question. Just said add or Kubernetes.
Okay, I think there's a next question being put, so maybe that's the right question. Can we install an instance of TIDB on cloud VMs like Azure and AWS? So thank you, Vipin. Yes, the answer is you can deploy TIDB on any environment which can host a VM. So TIDB can be deployed on a virtual machine. TIDB can be deployed on Kubernetes. So whether that Kubernetes is on-prem or on cloud, whether it's AWS, GCP, or Azure, you will be able to deploy TIDB there. Also, in addition, we also have something called TIDB Cloud Managed Service, where it's a complete managed service from PingCAP. So the end user only needs to open up an account and then start running their workloads. All the infrastructure, all the infra part of it is taken care of by PingCAP. For that case, we are currently on AWS and GCP, and we're going to be very soon on Azure by end of this year.
Oh, next question. Any examples of GenAI and LLMs applications that build with TIDB? and work around from MySQL-Compatible database like TIDB to support this application?
Yeah, so I think as I mentioned earlier, we basically, as of now, do not support such use cases on TIDB. But we can always discuss offline if there is a specific requirement you have. We can either get connected on LinkedIn or Slack, and then we can discuss further and understand what kind of use cases are you looking at. And happy to have a conversation.
Okay, next question. TIDB Cloud, is it possible to bring your own cloud provider? And which cloud provider is the default if I'm not bringing my own cloud provider?
Okay, so for TIDB Cloud, as I said, we are only hosted on AWS and GCP as of today. And we plan to bring TIDB Cloud on Azure, which will be end of this year. So when you say by default, I'm assuming that where is TIDB Cloud available on which marketplace? If that is your question, the answer is that you would find on AWS and GCP marketplace, you will be able to find TIDB Cloud there. Right. We do not have plans to host TIDB Cloud on any other cloud provider, like, for example, Huawei Cloud or Alibaba. That's not our plan. Our plan is for now, to be on these three cloud vendors, AWS, GCP, and Azure.
All right, thank you. Any more questions? So if no more questions, I think that's all for today's meetup. Thank you very much for your time. And please wait for our future announcement about the future event. Okay, next question. Oh, I see, thank you. Question, is there any free tier available for developers to try?
Yes, there is. So we also have our serverless offering. So you can always log into TIDB serverless. You can find the TIDB serverless. You can open up an account and you will get a free account there where you can start trying out TIDB.
Cool. Last call. Any more questions? All right, I think that's all for today's session. So we will announce more events at the meetup.com platform. So please wait for our future announcement. Thank you very much. So see you in next session. Bye.
Thank you.
Thank you, everyone.